The salt clips. I was like, yeah. It's like, because once we get it in, they're going to erase it. So. Yes. So I think it went well. I didn't listen to you. There we go. You guys like create like a strip or something? Yeah, I attempted to, and then they both refined it, which is good because I'm not nearly using this proportions. Pretty good. We pretty much have it done. Yeah. We'll talk about it. About 100 since the start of it. So introduction.
Plus the compliments. Yeah. 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 Masters. With Larry Baker and Bruce Wilson. So also still down at EBE. That's also the program that I'm doing my research assistantship with. Actually, that's Michigan State Environmental Geoscience.
All right, let's get started. Today's final seminar for the semester, yay, is given by Doug Klimbal. And he's doing a master's degree in WRS. His advisors are Larry Baker and Bruce Wilson out of BBE. And Doug has a bachelor's degree from Michigan State University in environmental geosciences. And he's going to talk today about his research on road salt. So take it away.
Hi, everyone. Thanks for coming in today. And if there's anyone out there online, thank you for dropping in. There's a pretty heavy student presence in the audience today, so we're going to have some fun talking about road salt. We're going to start off with a little introduction. What's been done in the field, especially pertaining to the Twin Cities metropolitan area, and where the results of some of my research with Doctors Baker and Wilson has gone, and where I have a feeling that the research is headed in the future. So I'm going to start with a map. If I can get, everyone always has this thing where it's like trying to figure out which buttons to push to advance the slide. So this is a screenshot I took just yesterday of the Twin Cities metropolitan area of chloride impaired waterways. You can see near the center of the screen here a little white marker surrounding a green dot. That's really close to where our research site is located in the Twin Cities, the 9 Mile Creek Watershed District. Back in 2014, I believe it was, 9 Mile Creek Watershed District, the Watershed District had a TMDL prepared for chloride. That means that there were 3 or more chronic level exposures measured in the stream channel throughout the course of some monitoring period. And that meant that there was too much salt going in. You can actually see that as of when I took this screenshot yesterday, only a small part of 9 Mile Creek is still registered as impaired. I haven't had the time to look into this, but I have a feeling that has to do with the altered hydrology that the system faces, because there are parts of the stream that have such limited base flow that it becomes ephemeral. So you can't really say that it's chloride impaired when it's not a stream anymore. So advancing forward, we're going to zoom in on the 9 Mile Creek Watershed District. You see a couple pretty pictures here. On the right, the top one, that might look like ice to you, but it's actually salt that is crusted up over the rocks subsequent to the spring melt. These are taken from the 9 Mile Creek Watershed District's website. And then, of course, the bottom one is a really pretty restoration project that they've done. So you get a little bit of both, and you can see some aspects of the land cover. This was from the TMDL report, and it's not really optimized for a PowerPoint presentation, so I apologize, it's a little bit grainy. But what I can tell you is there's a lot of really high density commercial centers and residential centers in this area. Hey Larry. And that has a major impact on chloride loading in the watershed. So we'll talk about the watershed a little bit more here. I'm presenting some information by Heinz Steffen's research group from a paper published in 2008, 2009 by Eric Novotny, where they studied over the period of 2000 to 2005 salt inputs and outputs in different Twin Cities metro areas to determine what's coming in, what's coming out. And they found out that in a lot of watersheds, the road salt that's put into the system is retained. Over the 5-year period, year to year, they saw 72% average retained in the watershed from road salt inputs. So that doesn't factor in water softening salts or stuff that gets sent to a wastewater treatment plant. This is exclusively from road salt chloride. They sense upstream in the Mississippi, they sense downstream in the Mississippi, and then they factor in all the other inputs throughout the course of that equation. It essentially comes down to application minus the outflow measured. So where is that going? A lot of folks feel that it's getting caught in the lakes and stormwater ponds. There's definitely evidence that suggests that it's building up in the shallow groundwater, especially. I think it's something like 70% of shallow groundwater wells that get monitored have elevated levels of chloride. We're really nervous that it's getting into deeper groundwater, or there's also some evidence suggesting that maybe not over the course of a multi-year basis, but some of it can get retained in the terrestrial landscape. So building off of that, it was really important to continue this kind of mass balance approach and look at the different settings that we have together. There are some workers that are focusing more on like a larger catchment scale. And our research is focused more on a small residential scale. So here I put together this flow chart that kind of details the pathways that road salt can migrate through the environment. You start up here, and it gets applied on the roadways so that we can drive in the wintertime, right? We wouldn't have road salt if nobody used the roads in the winter. From there, it gets plowed onto the road shoulder. You can see that large arrow going into that puffy little cloud. And it goes down into the storm drain and out into our little pond with all these pretty little plants here. But it doesn't all follow that pathway. There's a big question mark about the amount that goes down from the snowpack. You see that some of this is infiltrating into the water table, and there's even some exchange between the water table and our shallow groundwater, which is pretty typical in the systems that we have here in the Twin Cities area. I personally have read a lot of literature that suggests that there can be some minor net deposition throughout the year and sequestering of chloride related to biological activity. When you're looking at longer timescales, the bulk of chloride speciation is in this inorganic ionic form of just Cl minus. So that's really important to take into account that for the most part it moves with the water. But depending on your timescale and the environment, it might be important to take into consideration some other effects. Here's a little close-up of what we have going on here in the storm drain, the snowbank, and the roadway. What we have is the catch basin, that we're monitoring at. We actually have a sensory suite that is housed right here in the catch basin where most of the water is moving through. And one of the reasons I included this slide is to kind of detail the amounts of heterogeneity that we see in this environment. It makes it really hard to kind of be able to predict, once the salt is out there, how it's going to move from day to day. You talk to snowplow drivers, and one thing they'll always say is every event is so different. You really have to play it by ear. And that goes so far. But it is important to recognize that when it comes to pathways, there's heterogeneity in the snowpack, where you get some of these ice lenses that can affect flow path. And conversely to that, you get some preferential pathways where I think in glaciology they're called boudins, but the idea is that the water has drilled down through that snowpack and you move a lot more water through it that way. This ice lens also starts to proliferate near the front of the snowpack underneath, where you just get ice building up and building up and building up. And of course, you have frost, so that would inhibit water from moving through the soil, but that's also dependent on the amount of water that's in the soil when freezing happens, and if there's freezing thawing dynamic through the winter. So it changes. End of the day, we still have every reason to believe that the vast majority of chloride is moving into our storm conveyance and out to our waterways. So when we're talking about de-icing, there are multiple stakeholder parties involved. We have MnDOT, which has put out this was published in 2012, the most recent handbook for snowplow operators. That was the second edition. I believe they're working on a third right now, but the bulk of this is MnDOT telling municipal parties good ways to store their salt, good ways to prep their vehicles before the winter, rates to apply the salt during the winter, times when they should be using anti-icing, and ways to decommission vehicles as well and clean up after the winter. And all of these things, they can only go so far with making them work. So next it comes to that municipal agency. In our research site, we're working with Edina Public Works, who goes far and above the call to service for these operators. They have an amazing facilities department and operators who really do care, which is good because at the end of the day, they're the ones who decide how much salt goes where and when. You know, they do have these big team meetings, but it comes down to one person driving a truck with a controller and a switch that goes up and goes down, a dial to control how much salt is going down. And they need to provide a level of service that is safe and satisfactory to the people that they serve. They're obligated to. MPCA is also a big stakeholder party because what are we talking about? We're talking about the impairments of our waterways. And they have legal responsibility for the water quality in those systems and the biological integrity of those systems. When the MPCA recognized the water quality in 9 Mile Creek, a TMDL was prepared, and that meant that 9 Mile Creek Watershed District had a lot of motivation and a legal responsibility to start increased monitoring and outreach with the public. That some of that public is the Public Works Agency. A lot of that public are citizens who may or may not really know what's going on and why it matters. So since that TMDL was written, there have been a lot more concerned citizen groups, kinds of groups popping up, especially in that area. There's one that has gotten some legislation on the table over the last few years called the The group is called Stop Oversalting, and the focus of the legislation is to limit the liability of private operators in applying salt, because MnDOT gets to tell the state agents or the public agencies how to work, but they have no authority over private applications on private properties, right? So it's a really intricate system, and everyone getting on the same page is the way that it's going to be fixed. So I'd just like to take a minute and see if there are any questions at this point, because after this we're going to move into some of the methods. I know that I've talked a lot about this setting, and I haven't really made any attempt to make a case for whether or not chloride's a problem. And I've kind of figured that at this point we had Mike Trojan in here earlier this year, and I kind of figured everyone would be on the same page. Cool? All right. So we're going to move into the methods. We are kind of throwing the kitchen sink at it. Because Edina Public Works is so well outfitted, we have a lot more data to work with than some other settings. We've developed a novel method for monitoring the stormwater runoff in situ. So we have sensors in the catch basin that can monitor the conductivity of the solution, and the flow rate and the temperature. So based off all of that, along with a little classic getting out there and taking hand samples and running them to the lab, we should be able to develop pretty well what the loading rate is in this small system. It's pretty well controlled, and I'll talk a little more about it later. The trucks are outfitted with computers that tell us things like application rates, geolocation, speed the truck is traveling, the direction it's traveling. We are doing multi-scale analysis. So I'm looking at a very small setting. Larry has been focusing on some data provided by MWMO, the Mississippi Watershed Management Organization, which does most of the monitoring throughout Minneapolis. So it's a rather large, and I think he has data from Capital Region that we're looking at as well. So those are focused on some of the large drains that have a very large catchment. We have the small stuff that is very residentially focused. And as I said before, there are folks looking at the county highway kind of setting, or the larger residential setting as well. The first year, we also started taking a look at the snowbanks, and after some preliminary findings, we decided that it would be worth looking at them a lot closer. So our team spent a lot of time this year out in the cold, crawling into the snowbank and taking cores, and I'll talk a little bit more about that. But the idea is that we want to know how much of the salt that gets put onto the roadway does end up moving into the snowbank and interacting in that setting before it makes its way into our storm conveyance structures. Aside from that, taking meteorological data so that if there are any gaps, we can make correlations with, or at least try to make correlations with the meteorological record. That would be things like air temperature, wind speed, precipitation, and snow volume that's already recorded on the ground. So without any further ado, here is our monitoring site. We have a small residential drainage outside of a shallow lake that's on the side of a highway, and just across that highway is 9 Mile Creek. So our small catchment drains directly into Lake Edina here, which has an outfall that goes right into 9 Mile Creek, and that lake also has a very low residence time. That green dot that you saw earlier, that green dot says there's not enough data to determine whether this body is chloride impaired, and that green dot was over Lake Edina. Our drainage has half a kilometer of roadway that's 30 feet across. The catchment itself is 2 square kilometers, and there are about 15 driveways that drain into it, 15 parcels that interact with that stretch of roadway. It's east-west facing, and we're looking at the catchment on the north side of it. And most of our snow monitoring was coming off of that south aspect slope on the north side of the road, if that makes sense to everyone. So it gets really good sun exposure. That's key to keep in mind. What we want to do is take a look at the sources of chloride. They get put into runoff along with our meltwater and any debris that might have been on the roadway or on the shoulder. A lot of that is leaves and grit. We kind of use a coarse filter, a graded filter. So this year we're using a pre-filter that's about 1 inch by 1 inch grate. And then below that we have Geotex that I think is just a few, probably about ½ centimeter maximum pore size. So that kind of gives us an opportunity to get clean water moving through there to measure conductivity at the base of that probe, as well as not impeding the flow rate. Yeah, David?
So you want to just explain what is K?
That's the variable I'm using for conductivity. And that's I'm glad you brought that up. I might use that later in the presentation. I try not to use conductivity and chloride concentration completely interchangeably because they are different metrics. Although when it comes to sensing, they have a very direct relationship in this setting. So I'm glad you brought that up. After we get the interaction in that probe, we can quantify flow rate as well as the conductivity to infer concentration and loading, and that just goes out to Lake Edina and we pick up the data later. It just stores on a backlog that stays above the storm drain. Next up, we have the plow trucks. I'll talk a little bit more about that. Like I said, it sits in the controller. There's a little data logger in the controller that they use to apply to determine the rate of application for salts. It's pretty smart. It can, once you calibrate it, it can adjust the rate of application based on the speed of the truck, so that you're constantly staying at, okay, the roadway is this temperature, I'm supposed to apply at this rate of salt, and I can move with traffic and I don't have to worry about turning the spinner all the time. So that's pretty great. The technology that Edina Public Works has outfitted their trucks with is pretty top notch. While the truck is out, it's recording geolocation, application rate, speed, etc., and storing it on that computer in the truck, right? It gets back to the facilities. It can tell that it's connected over Wi-Fi to a server at that facility, and it takes that backlog and sends it online, stores it there on the cloud, and then we get to view it later. One thing that I note here is that preseason calibration, as it's said in the MnDOT manual, preseason calibration is incredibly important because if you don't have that calibration right, you don't actually know what's getting thrown down on the ground. Our snowbank sampling, this is where I get to use my prop. So we're going out to Edina, pulling up on the side of the road, and measuring 6 feet from the curb, right? There's a bunch of snow over top of it. Right at the curb, pluck this down. There are height measurements on here. This was designed by Brian Hetchler, based on some diagrams from a book called Handbook of Snow that Bruce had sitting on his desk, and I said, hey, I'd like to look at that. So I'd actually like to pass this around if you guys are interested. It's essentially a coring auger that you can just hook up to a handless drill, or a cordless drill. So it's super portable. And once you drill down and get resistance from the ground, you mark the height, you pull it up, knock the snow out into a bag, and move on to the next one. Doing a transect of 6 feet probably took a half hour once we got the rhythm down, which is great because you're out there in 10 degrees on a good day. Bree knows. Melissa knows too. My gosh. So we spent a lot of time doing that this year. I'll show you some of the results from that later. Let's see, what are some of the important things to take into account here is this bottom. So when I was reading Handbook of Snow, a lot of the standard practices for snow measurement were done in the Mountain West. And they recommend that you drill down until you can get a plug of soil at the bottom of the core, and that'll keep it from sliding out when you pull it up. Now, they're usually dealing with powder, so if you're not pulling that out, or at least some of it's powder, so if you're not pulling that out with a plug of soil at the bottom, it's just gone, and you're going to have to do it again. We were in someone's front yard, so we had to make sure we tried not to do that. There are some samples that came back with a little bit of grass clippings in them. But that was a minor difficulty. And just generally keeping track of where you are taking these samples, because it's destructive sampling and you're disturbing the area around that transect. Probably 2 feet on either side if you're doing a good job, because you're kind of wading through 3 feet of snow and trying not to fall in. So you have to keep track of where you're taking these transects because they get covered up by snow, but if you go back to the same spot, it's not going to be a representative sample of the rest of the setting. So we went up and down the side of the roadway and did some on the south edge as well. This should say year 1 cumulative loading. This is results from in the catch basin. I presented this graph at the Water Resources Conference last fall. So one of the major findings was disproportionate loading. I feel like one of these slides got out of place, but disproportionate loading of chloride based on the amount of flow that you see going through the storm drain throughout the year. You see in 10 days of year 1, 65.5% of the chloride that moved through the storm drain moved through in 10 days, and by 40 days, 96%, so almost all of it. And I have to tell you that based on some of the results that we've got this year, we have a new curve for developing concentration based off of conductivity. I sincerely expect this curve to shift left. It's that strong of a relationship based on the preferential elution. That's why we use salt, is to get the ice to melt, right? So it stays soft when it's on the roadway. We can pitch it off to the side and worry about it later. But that also means when it's on the snowbank, it's going to melt at 15 degrees, 20 degrees, whereas the rest of the ice is going to melt at 40 degrees, 35 degrees. We presented this to the snowplow operators and management team and the water resources administrators at Edina Public Works last year around this time, and got a really big reaction. So it was a big meeting. We probably had 30 people, 40 people there. And you see these 2 events that are highlighted are some of the more significant. These are those 10 days that accounted for 65.5% of the loading. And these are the types of days we wanted to manage. That's the thing we wanted to get through to people, is this is how we're going to decide where we change our management practices. So we'll flip over to the hydrology. I'm sorry, I didn't explain. So this shows chloride loading, average concentration, maximum concentrations. Chloride concentration is on the right axis. You'll see you'll see a lot of concentrations above that life use standard. That's not a huge deal in this setting because it hasn't been diluted at all, as it will be once it gets into a setting that facilitates aquatic life. But it's still something to worry about because you have a shallow lake that's primarily in this time of year driven by snowmelt coming off of the roadway. So if that's the major input, then the biota in this lake are going to be exposed to similar levels of chloride. So from here, we have big loading. We'll take a look at the hydrology, and you have to see that there's not a clear pattern in the hydrology of the events. Some of the highest loadings occur when there's not a whole lot of melt, but there's a lot of salt moving through, right? That may end up presenting a unique opportunity for management if we can divert some of this flow into storage reservoirs and have some kind of use for it. At this point, that's kind of an expensive idea, but we may get to the point where there are systems developed to account for that. So that created a lot of discussion last year, and we'll come back to that meeting later on in the presentation. Here's some really preliminary results from this year. So we just got our data back on the 21st of last, so about a month ago. And I mean, y'all know how grad school is. There's a lot going on. This is what I've got so far for results from this year with respect to the disproportionate loading. This year was a lot different from last year. We didn't have as much in the way of early season snow followed by some kind of mid-period melt. You'll see the biggest loading day was December 27. That was pretty much all of the salt that got applied through the first half of the winter. And then everything just kind of stuck around until the spring melt. I'll add in this little caveat. I left a note down here. Our monitoring scheme wasn't perfect, due in part to our data logging practices, and also due in part to just sheer physics of batteries not being able to operate when it's super cold. We had some gaps, right? The key thing to note here is that if you look back through the meteorology, okay, end of January through mid-February, really cold. I think y'all probably remember that pretty well. The one period that I'm going to be really curious and learning about is the period just before March. I believe that should say March 11 on there. March 10th, March 9th, March 8th. I recall very clearly that there's a lot of flow going through, and previous to that, there wasn't. So that'll be really interesting to try to get some regression to meteorological data along with the inputs from our trucks. Should be able to work that out and get a good estimate of how much was going in through those days. At that point, December 27th is probably out of the running for first 10 days. But yeah, this year we got way more disproportionality. That's 95% of loading in 10 days. This is going through the year starting November 15th was the first time that trucks were out this year. As I noted in the previous slide, not all of these days are going to be consecutive. I didn't have a really good opportunity to format this slide. But you have daily chloride loading on the left axis. That's in grams. So you're talking about levels upward of 15 kilograms a day, upward of 20 kilograms a day. And we're still working on these numbers, along with flow on the right axis. So the one thing that's really clear here is the predominance of the spring melt and transporting chloride through our storm conveyance. So, considering we have minute-by-minute data from in the catch basin during that period, I decided, oh, let's break it down by hour. So this is something that we haven't had the opportunity to do yet with the previous year's data, but it's definitely on the list of things to do before my defense in July. So you see chloride loading in the kind of orangey yellow and the volumetric flow throughout those days in the blue, and just a linear best fit for that period. What you're seeing here is the inverse relationship between flow rate and concentration, as well as the effect of preferential elution, where salt is moving out of that snowpack because it melts quicker, right? So pretty interesting to see that relationship in the spring melt, and there should be more data. And at the end of that, you might remember, what, 2 weeks ago we got about a foot of snow? Let's wait on that tomorrow, huh? Be fun to see if we get even more data to work with. And there's also going to be a precipitation event that we get to factor in here to see if there's any washing off of the roadway or other impermeable surfaces, or who knows, maybe even out of the shallow soils. If the frost was still around and you got ponding up over it, you could be flushing some chloride out. Yeah, things did get out of order. Anyway, so this is an example of some of the truck data that we're working with. It looks really fun, right? Report time, latitude, longitude, speed, granular setting. That means application rate in pounds per lane mile. So that's what we get, and this is what we need. It leads to a really, really lengthy process when it comes to data analysis. That's something that we're going to be working more with Force America, who provides this service to our snowplow operators and the public works management. But so far what we've got going on is November, I misspoke before, November 9th was the first time the trucks were out this season, through February 11. And we know that trucks were out after February 11, but for some reason we're having trouble obtaining that data. We have pounds per lane mile application rate, and we really would have liked to get the road temperature data stored in this spreadsheet, but it looks like it didn't really come through. So we might be able to pull it off some other trucks. I'm not getting my hopes up. The reason that's important is because that determines, that should determine for the snowplow operator what the proper application rate is on that, in that particular setting. They have a little infrared thermometer underneath the truck that tells them how hot the road surface is. And it, you know, when you're out at 4 a.m., 3 a.m., like some of these guys are working, that can be pretty low. And that might be why you're seeing average application rates upward of 500 pounds per lane mile in early February. If they're out there late at night, it's not going to be warm. These are some of the snow bank results from season 1. Guys, it took so long for me to put this little graphic together last year, and it's great. It's communicative. We saw some really high concentrations in the snowbank last year, and they went away in 2 days, and we wanted to find out more about what happened. We ended up changing the method a little bit. Instead of having that coring device last year, we had like a 3-inch pipe by 4 inches deep, and you'd take a section and then put it in a bag, and take another section and put it in a bag, and that just was too much work for the amount of data that we got from it. So we changed the method, and I'm going to show you some of the results of that right now. This is just near the start of and during the spring melt. We see concentration with units of milligrams per liter. Those are on the left side of each of these graphs. taken at individual times. I hope this is clear. I know it's a little bit disorienting at first, but, and then the water content based on the liquid water content based on the mass of the sample on the right axis. So you see clear changes. It is important to take into account the heterogeneity of the setting. If you could design, if I could design this, I would go out and have paired watersheds. I would do 3 transects a day over the whole course of the winter to account for some of that heterogeneity in the snowpack. So what you see is that some of the change over time, but you have to take into account that one sample is not the same as the next. So I just wanted to end with a quick comment on how we manage these events. The best thing to do, what we have seen results from in this study, is go out and gather a lot of data like we did, bring it back into a big room, get the snowplow operators, get the management, get the administrators into the same room, show them what they're working with, and then let them talk about it, right? Because there are lots of silos. And it's not just at the university, and it's not just in government. There are silos everywhere you go. And breaking through those is the only way that we're going to see effective change in a short amount of time, bringing someone else into the discussion. So what we had last year was we showed that data, and the snowplow operators started talking, and they recognized that we throw salt down to keep the snow soft so that it can just go over there. If you have better plows, you don't need as much salt. Snowplow operators started talking about that, and the administrator chirped in and said, well, we can find some money for that. Let's try it out. This year they've done that. We haven't had our operator meeting yet. That'll happen later next month. But it'll be great to get some feedback from all 3 of those different groups and see if there's a general consensus and if there's any way we can help them make decisions as to whether keep going in that direction or to take a look at something else. But that is the role of us in this study as scientists, is to provide information to aid in decision making. The end goal is to improve the quality of our waters, but we want to do that, especially in this setting, so that people can enjoy their lives more. People want to see lakes that have diverse biota and ecosystems that are well established instead of some regime of pond scum. And that's one of the things that a lot of folks are worried about when we're talking about chloride right now, is what effects is it going to have long-term, especially on macroinvertebrates? And what effects is it going to have on the fish and the plants? We're in a freshwater state. We're in a headwater state, and biology doesn't keep up that quick unless it came from the ocean. So I want to end on that and say thank you. Larry Baker, heading up this project. Bruce couldn't be here today, but I wanted to thank him, MnDOT, and the project TAC, Derek Ferguson and Brian Hatchler. Derek really helped us get us off the ground with fabrication on some of these parts and installment and deployment. Brian has helped us out a lot this year. Christy Wallstrom was an undergrad. She's now, I think, working at MWMO or Capital Region. Dan Fruta and Pete Marchetto. Dan is a grad student, and Pete is his advisor down in biosystems, bioproducts engineering, as well as Jacob Bierman, who started with us last year as an undergraduate researcher, and Melissa, who's doing her UROP on some of our project materials right now. So couldn't do it without all y'all. Thanks. And I'm happy to answer some questions. Bree.
How much do you think private application affected your samples?
Affected our samples? So the case in which that would happen would be if some of those driveways were salted by private applicators. Common practice in this state is that the plow companies don't salt, and the salt companies don't plow. And when we were out there, we saw plenty of people getting their driveways plowed, but never really saw anyone getting professionals to apply salt. So I would say in our setting, 0, unless people are bringing in a whole lot of it on their vehicle. There definitely could be some from what gets thrown down on someone's driveway by the homeowner or someone's walkway by the homeowner, but I don't think it's a significant amount.
On your hydrograph, there was a lag between the chloride that entered the system and the flow.
Year 1 or year 2?
Oh, I don't remember which year. Keep going back. There, that one. Like
Yeah.
Day 90 or so. Pretty big shift there between the yellow and the blue curves.
Mm-hmm.
I have my suspicions about what's causing that, but I'd like to hear your ideas.
So I would say that it's an effect of the energy that gets transferred into the snowpack. That late in the year, it was really well developed, and you can see that there was plenty of salt in it from some of our sampling dates. That does actually coincide really well with the graphs I presented here. So you're looking at chloride concentrations in excess of 1,000 milligrams per liter. At that concentration, you're starting to affect the amount of the melting temperature of the ice that the salt is interacting with. So you start to get some energy into the snowpack, and the more saline portions, as it gets up to temperature, because energy transfer through a snowpack is pretty isothermal. So as it gets up to temperature, you'll have pockets that start to melt out because they get up to the right temperature. But the bulk of it that you see in blue is going to need a lot more energy to get into it. So that's going to happen during warmer temperatures. So my suspicion is that that's meteorologically driven by insulation. Can I ask what?
Yeah, I mean, it seems like, you know, you have, I don't know if the salt went down to the bottom because it melted through. And so, or if it stayed on the top, but if it stays on the top and the upper part melts first, you know, then, and it seemed like your data were kind of, they weren't all that consistent. Some of the snowpacks you measured, your highest concentrations at the bottom,
Mm-hmm.
and others it was at the top.
Mm-hmm.
So maybe it depends on like whether the top is melting and the salt is there, or whether the salt is at the bottom and it has to be washed out, you know, when the remainder of the snow melts.
Mm-hmm.
The snowpiles are not like homogeneous snowpiles. Snowpiles. And that might represent several plowing events, different weather conditions and such. On top of that, you do get preferential evolution. The chloride comes out first. There's one good study, I think it was, anyway, somebody at MPCA did it way back in the 80s, and they showed the pattern within a snow pile over a short period of time. Definitely chloride and water move differently in snow piles. A lot of chloride comes up early in the small volume. I think that's what you're seeing here in some places.
And I'd like to add that one thing I could definitely include in a presentation like this is some of the pictures that I took this season, because we spent some extra time out there just kind of shoveling to get a clean, you know, I studied geoscience for my undergrad, so getting exposures to look at strata is really stimulating for my mind. So getting out there and actually looking at what gets deposited where and how the structural aspects of it change over time as energy moves into it, and you might get melting and re-precipitation. It completely changes the hydrology from day to day.
I'm gonna run off, not being rude, but Kathy Evans is having her retirement party.
Yes.
I'm trying to catch the last half hour or so.
Okay. Wish everyone the best for me. Thanks, Larry. Yes, Jack.
So you show that most of the salt is being loaded into the system in a 10-day span, and not technically a consecutive 10-day span, but is that not, and it's not correlated with flow, although this one seems it's sort of correlated with flow, just a little bit lagging of discharge in the stream water.
Mhm.
Is that basically saying that once the salt is being laid down, it's going through pretty quick into the system, and the then spring melt might carry the rest of it with it, or
Salt gets put down, it moves up into the snowpack, and it might be buried there, where it might be on top, as you were saying, and it just needs the right conditions to get up to the proper temperature to melt out and move into. Because one thing that I think might be helpful to keep in mind is that these data are developed from in the catch basin. It's not developed from when salt's getting applied, right?
Yeah.
Is that helpful at all?
Basically, it gets stored until something switches it, and then it all of a sudden flushes.
Yeah, and I don't have any because of some of the things that I read in literature on snow measurements. I have reason to believe that everything that's in that snowpack is going to be submitted to very similar energy dynamics. So it would come out all at once. Plus, it's all deposited at same times,
Yeah.
right? So different days at the same rate gets pushed up by a plow later or by car tires. So it's in a reasonably similar spot.
Yeah, okay, so that whether it moves to the snowpack or not, it's probably moving together.
Yeah, I'd say that's safe. Also wanted to point out that Bree brought up private applicators earlier, and while I did mention that they're probably not huge in this setting, they are a massive control on the loading that occurs in urban areas in general. And just up the street from here is Ridgedale Mall, for example, and all of those parking lots are going to get paved with salt by private applicators, just to keep the landowners from being liable for injury that happens on their properties, and getting those folks to be on a similar page and getting the general public to be on a similar page as MnDOT and the professional applicators or public works applicators are, definitely a step in the right direction. So, yes, David.
So the photo you showed of your study area was kind of a residential street.
Mm-hmm.
I am a little confused because, you know, in the area that I live, they'll plow the snow after it snows, but they'll never apply salt on the street. So, I mean, are they actually applying salt on this street? And if so,
Oh, yeah.
why?
It's a primary plow route, and that is a primary plow route. This neighborhood has primary routes because of the demands of the people who live there.
It still looks like a pretty small road. I don't know why they
And it even has a turnaround.
does.
Yeah, you can see further down, but those data that I showed you from the trucks were geolocation filtered. Those were only taken within this tiny little view shed. So we know they're going through.
But the amount of salt that's being applied there compared to Highway 100 is probably minimal.
Well, Highway 100 is maintained by the county. So I can't speak as to what their operations are like. They should be following, everyone should be following the MnDOT application guidelines for the, you know, by and large. That's a good point. That's probably maintained by the state.
State highway.
France Road goes through that neighborhood as well, and I believe that's maintained by the county. So yeah, there are different standards in every community, and that plays a role as well. We all need to play our part protecting the waters. Yes, sir.
This is a general question. So, well, what type of salt gets applied? It's a chloride salt, but what's cation?
It's a good question. So in this, by and large, we're working with rock salt, which is mined. It's probably 80+% sodium chloride. Sodium on its own has some other severe environmental implications.
That's what I was going to ask you.
Yeah, so sodium can be related to corrosion on industrial materials as well as weathering of soils. I haven't seen a whole lot of research in relating road salt application to soil erosion, but I'd really love to, as well as the weathering of the building materials such as asphalt. If the temperature gets cold enough, they start using magnesium chloride, and they can also use other, calcium chloride or other magnesium salts that may or may not be chloride salts. And everything acts a little bit differently with respect to melting point temperatures, or freezing point temperatures, but also the implications of its use, and probably even more importantly, the cost of the material. Yes, sir.
I'm just a historian layman, but you see, so we see these places like on the campus where the land management trucks will put strips of brine down.
Yeah.
Before, and then you'll read that brine is actually from, it's a byproduct of various kinds of food production and things like that. What is that compared to what you're talking about here, and is that liable to have any, I mean, it's bound to have some kind of implications for less salt, or otherwise it would do it.
That's a really interesting story too, because MnDOT will just use a cleaner source of sodium chloride to produce brine. That's my understanding. Edina Public Works will use that same kind of cleaner processed sodium chloride, and can add magnesium chloride as well to improve the efficiency of the melt. And there are communities that you read about who are using cheese brine.
Yeah.
And gosh, if I know what cheese brine has in it, I would assume that most of it is salt, sodium chloride, but also maybe some acetate. That's known as a freezing point depressant as well. So there are lots of communities trying to come up with lots of different solutions for what's called anti-icing to help reduce their road salt application. And I think by and large it works. And if you can find a product that is upcycled or reused, however you want to look at it, it's all the better. But I don't know anyone using cheese brine around here.
Wisconsin.
Yeah, well, they're out there. Anything else?
Thank you.
Yeah, thanks.
Thanks, everybody.
Helping out this semester. And more science.